All right, folks, can you guys hear me well? Just testing.
Yes, Ism.
All right, is that okay? This is oh, he's recording this, so it's good. Sorry, I couldn't figure out. Let me see if I can figure out to make my camera working, but I'm not sure. Kind of damaged. It's here.
Are you using your laptop or are
Wait a
you using?
second.
Okay.
Trying to get my speaker also. This is connected. Why can I hear this in my ears? Oh, okay. Microphone array. I should be able to. Mhm. Mhm. This is connected. Why can I? Oh, there we go. Oh, that's good. All right. So I'm just switching. I just switched my microphone, so that should be better. Or which one is better? 1, 2, 1, 2. I think the headphone is better. Yeah. Okay. So you guys can see my screen. I couldn't figure out my camera though. Sahil, is this Java, right? Java, and then this is the
Yes. Yes,
and this
Ism.
is
This one is
the
Java.
are we doing the like multiple sessions of like a basics, intermediate, and advanced? I
Yes,
still
Ism.
you still on that, and this is the basic, right?
Yes, Ism.
Okay, and then this is till 3:30, is 1 hour.
Yeah, 1 hour.
Okay. All right. Let's just ask since we have like 4 students here, and this is like a workshop style. Is any particular topic you guys are interested in Java? Or you have the Java this course this semester, and or just there's area of the Java you're not comfortable with? What's going on? I want to know where to start with you guys. Apparently this is the first. Let me see. Here we go. Well, it's the workshop one of Java. All right, so ADK. There we go. All right. Any particular topic you guys have in mind? Let me take a look at. Okay, that. I'm gonna keep the chat on the side. There's out of office. Okay. All right, so I'm gonna go through the basic of Java. At least like I wanna focus on two major concepts that is helpful in the intermediate and in the advanced Java as well, right? The concept of so as you guys know, Java considers object-oriented programming, right? Languages. Meaning what? Right? Means it's basically class-based. Means there's a hierarchy. There's a hierarchy Java has, which is does anybody know what that is? It has packages, right? No, wait. Yeah, packages. And then inside the packages, you might have multiple classes. And then inside the classes, you have multiple method. Well, we call it method in Java, but basically, these are functions. So if you did any programming languages, you understand. Okay, so now what you see in front of you is a main class and is a main function. So you may have multiple packages, which inside of them you have multiple classes, and inside each class you have multiple functions. So this is the hierarchy we follow. Now let's talk about classes, because any object-oriented programming languages could be Java or such, like C Sharp, C++, all of them. They have this concept of classes. And what's class exactly? Does anybody do know that? Let me see. Does anybody want to elaborate? I want to see how much you guys know. It's not a lecture mode, right? It's not like me talking and you just guys listen. I want you to, especially the number of you guys are not much. So tell me what you think and engage. That's good. Does anybody know what a class is? Wait, let's see in the chat here. I just can't find my chat. Uh, you guys can hear me, right? Because I'm talking to myself here. Hello? Can you guys hear me? Can you guys hear me, or my mic is just a shy people in this? One, two, the mic working just fine here. Oh, I cannot. All right. Okay. All right, keep going then. All right, so classes is what we can use for two purposes. One is you can use it as a container for a bunch of parameters and function, bunch of related parameters and function. Right, so that's one thing you can use it for. Here right now, you can see a class main, which keeps all the things related to the main program, right? The function, that's function main, and any parameters you might have. That's one use of it. You can create all classes you want. Let's say I want to have a class called, I don't know, math, or let's say payment. And inside that, I can keep anything related to the payment. Um, which is, let's say I can have a parameters here, and let's call it the HSC, right? Which is the 0.113, right? That's a float. And then we can have different functions such as, let's say, calculate HST, right? Which is this is a function. Now, you might say this is one way of using that. I'm not doing it right now, but I want to say like you can have it's called a container. You can put anything in them and separate them, right? It's kind of a divider. Now, this is one use of it. The second is the use of the class for something called object-oriented databases. Now, this is a big word, but what it means is basically using it as a data structure or a template for your data. You might say, what's the difference? So here's another class here. Let's say I want to create a class student, which keeps the student parameters in there. Let's say you guys have a ID in the form of a string or text. And let's say you have your mark, which is usually float. That's a final mark and stuff like that. You can have what else the student has? Name, I guess, right? Anything that is related. So this is a data structure right there. Now you might say, what's the difference between that and this? So there's two user class. One is a container, and two is as an object-oriented database. Now, how do we distinguish these two? Right? It looks the same, right? This is the container for payments and then HSTs, and then I don't know, any related payment functions that we can do. And then this one is just a template for objects or basically your data structure. How do we distinguish these two? The distinguish goes with the distinguish goes within these keywords. So when you're using the keywords here, it's called a static, right? Means static means then using the class as a container for a bunch of useful and related parameters. So here we're gonna do this, right? So this is non-static, but can go static here, and this is makes this static HSD, right? And then this makes it to act class as a container. Means anything you mention static means belongs to the class. Means you can access it directly. Okay, well, that's great. So let's say I'm in the main class, and this is like a main static method, means that can I access directly. Now, if I want to get the HSD and that's static, right? And go to the payment and then go dot and HSD shows up, right? So let's say we want to calculate the HSD on $100, right? And that would be the tax paid, which is that much, right? Now, you want to print that and see, here we go. Okay. Here's the $13 you have to pay. Now, this is a static parameter. Means you can go to the print and directly access that, so can reuse. Now, if you don't make it static, what happens? It says, oh, oops, this turns red. Red is not good. It says non-static field cannot be referenced from a static context. So how do we access that then if it's non-static? If it's non-static, so if you have a lack of class, a lack of keyword static, or non-static really, it belongs to the object. Okay. All right. So if it belongs non-static, how do we access that? Well, in order to do that, you have to go ahead and create the object out of this. So we're gonna go create a new object out of the payment. So this is creating a new object. It's called the constructor, and then you can see the HST shows up. But that is that. You can actually store it and say, oh, this is a form of a payment called a payment one. So idea here is this is not the way to use this class, obviously. I'm just showing you the difference. Because what's the point of making a data structure for this, right? For a student, it makes sense. You can create different students. But for the payment, it doesn't make sense. So they have a payment P, and then you can see the HST, right? But so if you want to use it right now, that's how you do it. So that's the difference. In this case, it does not make sense because when I have all the parameters related to payment, so I'm going to say it belongs to the class payment, so we can directly access. So then we don't need to do that. We go payment, not adjusted. Okay, so that's only. However, if I want to, let's say, using a data structure, and these are our non-static, pay attention to that, I can go ahead and create, let's say I want to create different student. So, okay, student number one, right? And this is a new student. Create that, construct that. So this guy, remember, this constructed student. That is, are we using the map? Means you have now one student that you can register ID, final marks, and name to that. And then go ahead and what's going on? Sorry. All right. My apologies. All right. So now we can create a different student. So that's your student one right there based on the, let's make this a bit smaller. Usually using this because I connected to the projector and then everyone can see that. Let me see, I have enough juice for this because, yeah, it's 11%. That should do it. Okay. All right. So in this case, if I want to create a new student, which is I do this, student one, and let's get some of you guys set you up. And then you can go, okay, now I have the student one. Now we have the object, you can set the ID equals to C0787878. And that is, so we're using this map to create different student. It's a sum. And then final mark, you got 56. So I'm using that as a data structure. And if I need to create another student, Control D, bring it down. So now student number 2 is Maria. I think we have Maria in the somewhere. Yeah, so it's a Maria. Your name is familiar, though, Maria. I think we had a class before, right? And then we can set those for student number 2. All right. So this is the idea of classes in general. Why I mention this, you might say, well, this is not beginners. It is. Because people just memorizing things from the beginning and say, hey, listen, like why I'm doing this, I have no clue. And this is actually helps you with this. To understand. So you have two ways of using classes, that and this. Right. Now, this is talking about classes. And then inside the classes, you might have a function like this. And this just tells you what this function. The function has two steps, right? Remember, these are static ones. So is like how we can access it. It can be public, protected, or private. If you make it private, it stays within this scope, right? So you can't access the outside of this class. So it's kind of accessibility, or so we have privacy and accessibility, right? So we're going to say, okay, privacy, let's say public, everyone can access that. Accessibility is we're going to make it static because you can directly access. So static is through the object, or it belongs to the object, or belongs to the class. In this payment of ours, it just wanted to create different payments. If you want to create different payments with different attributes and different values, then yeah, go ahead. And then it says what this guy returned. And this guy returns double, which is the decimal value. And then we're going to say, okay, now what's the name should be? We're going to say calculate HSD, right? And what happens here, we're going to receive an amount that it gives us. And remember what we did here. I'm just kind of this guy here. I'm going to kind of create a function here, so I don't need to keep doing that. And then what it does, it returns. What it returns? So this is the heading, and this is the scope says, oh, what's the body going to be? You're going to return the value you type in, type times the HST on the top, right? In this case, you can directly access the HST, or you can just call for calculation. Now, here it is that instead of that, you can say tax pay is go to the payment. So this lets you organize. And you see that now we have that. They're static, calculate HST for $100. So it's much neater, right? We can do that as well. So the function also can be static and non-static. It has a heading. They define what it does from like who can see it, how you can access it, what it returns, the name, and what it receives, and then the process itself. Right. So these are there. Now, talking about these two, so we talked a bit of the classes and then the function. There are two types of those, right? So classes and function. There's something called the predefined. There's somebody already designed those, and we just take advantage of it. We reuse it, right? And then there is a self-defined, right? Which is you doing that. And here they also refers to as black box. This is refers to as a white box. All right. So remember, at the beginning, usually the people gonna go use the predefined, but here it is that even like you're looking at the first program I run, they have this print out. They had this line that says "Hello World." Where does that come from? This comes from the class system, right? How do we know it's a class? It starts with a capital S right there, right? Directly access this function. So it means this function is that, right? So it does do that, something like this. Or let's say I want to create a random number. So when you want to print out in Java, you can go S out, system out, and press tab, and they just put the whole thing for you. There's a lot of details, but using shortcut really helps. Now, what we can do here is um, printing anything you want. You can print the tax paid. When the tax paid is $100, that's going to be 13. They print that for us. So we don't know how these things work. So what the reason we call this a black box is because we don't know what's in it. We don't care. We're just using it as a module. Or let's say even, now let's say I want to create a random number, right? So I'm assuming there's a class random, which is it is, and this has to be imported, right? This is called a packaging. So the packages, if you're looking at it, let's say the utility, for example, is a package, and then you go to random. You see, that is a class itself. Then actually is which is predefined. Somebody wrote that class first. As you can note inside this class, right? There is one static, which you can directly access called random wrapper, and the rest of them are not static. So what we can take a look, oh, they have a next int, for example, which generates the next integer if you need it. And then it also accept the boundaries to return that. And this, oh, it's interesting though. Look at this. Now you guys can kind of understand in a sense. That's the parameters, isn't it? Yeah. So this is the final parameters from the, okay. Yeah, that is aggregated, right? So that's that. Now, I'm gonna go back to this. Now we're importing that, and you go to the random right there. It's pretty fun. You go dot. What you see is nothing, right? So we have a from module, uh, and then there's a bunch of interfaces that I have no clue what that is. Start with I. There's no random because what you saw there, right? If you go to that, you can always hold the control, and you can see, oh, what you saw there is they actually the one that give you the next integer with that is non-static. There's no keyword static in there. It means you want to access those, you have to create an object. Okay, I can do that. I can create a random object, call it random one, right? And the random. And then when you go random one, that's an object. Now you can see the list of those, right? So you have to nowadays to know what to do with the existing one in Java. C# is the same thing. C++ is the same thing. It's like a object-oriented database. Sorry, object-oriented fundamentals, right? So when I go, okay, next int, give me a next integer between 1 to 100. And then I can go and say, okay, repeat this for how many times? Repeat this for 5 times. Okay. And let's just print that. So simple like this. This is what it does. Right? So here's your 352. These are the random numbers. Now, if you don't know what a loop is like this. So this is like a counter and count. Start initialize with the I is equal to 0, go up to 5, and it increments by 1. So it's plus plus, it adds 1 to it. We're gonna go 0, 1, 2, 3, 4, right? Up to 5. Because I has to be less than 5 for this body to repeat. So every time this will repeat 5 times and create that number. Now, here's the fun part. If you like these functions, you can customize, you can get this. We have that, and we have the object too. So this is how we did that. I can go ahead and create a nice little container for myself here and call this class process number, right? And create a static function. It's not returning anything. And it's a print random integer, right? That's what it does. And then we're gonna collect how many number number of digits, number of iteration, or how many, right? And then start and end. See, customize. So it's gonna tell me how many random number you want between what and that. And then you paste that here. So what happens is you create the random number. This guy goes from 0 to the how many. And then the bound would be what you gave me, start to end. Hey, that would be nice. So now we have a function. Anytime you need the random numbers, you can say I need one random numbers to print it. Now here's what you can do. Now we can go to the class we created directly, right? What's the name of it? This is number. And then we can call this guy. So I want one random number between 100 and 200. And you get 110. It's 907. Now you can run this even 12 numbers between that. Here's your 12 numbers between 100 and 200. So you see, with that, you can just go forward. Right. Let's get the sense of this. So summarize this hierarchy. Obviously, for the start, nobody start with that, but have like a little bit of different approach. I think it's good to understand how this system works, and then you looking at it can understand things much better. Okay. Now, I want to talk about this a bit. Okay, so we have let's see, ITGDSD. What's that? Okay, so you guys so far following? Is that too much? You want it simpler? So give me a bit of a feedback. Any topic you want to cover particularly? We talk about the hierarchy of it, but how these things works, the classes and the function, and that is important to know. But is any topic you are not comfortable with and you want to, or you have no clue what it is? If you can tell me, like if you've never seen a Java before, then I can also approach this differently. How about we create an application? Anyone got a suggestion? Anyone wanna create an application on the console, obviously? Let's design a game, for example, right? Let's just do the maybe a rock paper scissor game. Right? Or a guessing game, game. Do a game. Does anybody wanna yeah see a game? You guys listening, or it just seems I'm talking to myself here? All right, I'm gonna do the rock paper scissor game. Um, and maybe we can get the chance and do the Sheldon Cooper version of it. I don't know you guys tried it or not. Okay, so how do we design a game using Java? Right, primitive task, but it's interesting. So far, I'm going to close those. So I'm going to keep them as the reference. That's that, that, and that. Okay, so we have the main here. I'm going to let it be. So this is what we have. So what you want to do is a game called Rock Paper Scissors. Now, this is like computer versus human, right? Computer versus human. And before we start doing that, we want to make sure to understand. We need to create three objects. So call it rock, paper, or scissors. And we don't have those objects in computers, so we have to create those and let the computer select one of them randomly, right? Okay. So it means I need to keep the string computer choice of either, let's say, rock, papers, or scissors, right? But we don't have. Now, what I'm going to do is I'm going to create a list of objects. We need that. So I'm going to create a list of objects, object list, right? That's how you show it with the brackets. And in this list, we are going to keep the new list of rock. So this is what we have. If you want more objects, rock, papers. All right, so we're going to list in there. And then for the computer, you're going to randomly pick one, right? Random is really useful because what we can do, we can go, okay, go to the random. I need a new object, new random object. Then I'm going to go to get the next in from 0 to 3 in this case. But this guy right here should give me, in order to pick those, we use something called an index. Index point out to each of them. So start with zeros. That's 0, 1, and 2. So we need something, we need one of these numbers to pick those randomly, right? So we need a 0 for rock, 1 for paper, and 2 for scissors. But when you say bound 3, I think that will generate, let's just test that. That will generate a number between 0 to 3, 3 excluded. So let's test that. So we have 1 here, 2. Okay, that's good. Now I need to see 0. 1 again. All right, here's the 0. So you never see 3. So up to 3. Start from 0. Okay, so that's what we need. We print that. And for the computer, we can go to the list. And you can go to the list of objects. And we have the index for it. So we create a random index and go ahead and pick it up. So we're gonna go to the list. Let's say this is 0, we're gonna pick rock. If it's 1, it's gonna pick paper. If it's 2, it's gonna pick scissors. Okay. Now the computer, we can just print that. It says computer selected. Just checking whatever is in the computer. So in this case, I see computer selected rock, so that was 0. Paper this time. Paper again. Paper. He likes the paper. Scissors. All right. Rock. Paper. Rock. Okay, so that works. So we have that. Now, computer right now successfully pick an object. Now, what we need now is you have to pick the object. All right. So first, we're gonna show them a message. So, okay, enter rock, paper, or scissors. All right, and then we have to collect that from the user. How do we do that? Collecting input, this is the output, not a problem, but collecting input is a bit challenging in the sense that you don't know when the object's coming in, so you need to scan it. So there's a class called a scanner, which what it does, if you take a look, is right here, it tells you what it does. Okay, so it says the string can be part, no, wait. Push documentation. Okay. The scanner class, what it does, if you go to it, it has nothing in there, but if you go ahead and create a scanner object, remember, then you have to scan. What do we scan? System input. Now, system output, what we do it is we have something, we just pass it along. But system input, usually entering inputs, we have to collect, stream it out, right? Scan it out. We're scanning one at a time. So this is what you're going to do. And that tells you this is a non-static function based on what we discussed earlier, right? So we creating the scanner. So this guy scan the input. And then I said, okay, now go to the scanner. So scanner object that we did. And now you can see that. Go read the next line, right? The whole line, scan it and return it back. And that would be your user input, right? Now, what we have here is either rock, paper, and scissors, and then the computer also picked one. Now we have to find out who's the winner. So when we have these two things and we want to compare them, there's 9 different scenarios, right? So if you're looking at let's now talk logic. Rock, paper, scissors logic here, right? Well, that's a logic gate. Okay. Right, so that's good. You're looking at the outcome of a rock, paper, scissors. You might have rock, the opponent have rock, and that's a tie. So with 3 objects here, we have 9 different possibilities. But each of them can be, so it's 2 players. And it's going to be 3 to the power of 2. So that's going to be 9. So either tie, win, or lose. So these 3 major objects with 3 different possibilities. Now, if you're looking at this, you can check for all 9. So, okay, if you or user has rock, an opponent does that, then mention and tie. You might go one at a time, check that, and see which case is it. So we can say, oh, okay, if the we can say, okay, if the computer got equals in the, let's say, rock, and the user input is also equals in rock, then this is a tie, let's say. Then we can go ahead and print this as a tie, right? And then you can keep repeating that for 9 different cases. 1, 2, 3, 4, 5, 6, 7, 8, 9, and each of them like rock, 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 paper, paper, scissors, and then you're mimicking this number. It's pretty straightforward and simple. It does work, right? But it's not the best, right? So this is really, really basic. And it's okay. It's a rock, rock tie. Rock, paper. That is who losing? You losing, right? You lose, or the computer wins. I do that. And then you can say, okay, if you get rock and scissors, and you win, right? And then you keep going. Obviously, you can, since now we covered rock, it's going to be paper, and scissors. Now, when you're coding like this, remember, always think there's going to be a better way, man. Can't be like me copy pasting too much. I know you guys think like school is like that. You have to copy paste through the school. Not true, right? You're not doing it right. So, but for now, it gets the program running, and it's not a good thing to Okay. I'm going to talk about two concepts which is important here. All right. So we have that, and you have the win, 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 right? And then this works. Tie, lose, lose. Computer wins. And then you win, and it's a tie. Now you have that. That works obviously. It's really primitive, but it does work. So we can just run that. And let's give it a shot. So I'm going to pick rock. And then the computer wins. Oh, it doesn't tell me what the computer got, right? I'm going to do that when you enter. I'm going to print computer has whatever computer does. A little bit of weakness here. That's who wins. So I'm going to go rock. And rock, computer has rock. And that's a tie. And one more time. Let's have paper. Computer has rock. No outcome. Happens so. I missed something. Paper, computer, paper. Okay. And mistype it. And the rock, it says Ewings. Didn't do that. Want to mistype it? Paper. Ah, wait a second. Sometimes you want to do it wrong. Okay, so none of this is true. Why is that? So computer, you have the raw, you have the paper, and then computer has the rock. That is what it is. So why this doesn't work? Oh, there's the lowercase p. Case sensitive Java. You have to be careful with that. There we go. Right? So this is working. Now, this is not the best way to do this. I want you to think about that. This is like a really primitive way of doing it. You exactly have a situation for each case. Now, there's two concepts. I want you to look into it for your own sake. And these two concepts are called pattern recognition and data representation. And the other one is something called abstraction. Abstraction here is not really useful though, but I'm going to talk about pattern recognition and data representation. Means the problem with this is we did not consider data correlation because none of these nine cases cannot be like it's only one of these cases can be true all the time out of these nine cases. It's not like just every single one of them can be true or every other one, right? So we forgot to consider the data correlation. Now, looking at this, I think I can write on team, right? I want to do annotation here. Now, looking at this, right? Looking at the pattern here, creation of the background, okay. Now, looking at the pattern here, right? So if you want to just talking about this, right there. Now, there's a pattern. So let's say this is the case you can do. This is one pattern. It says go rock, rock, rock. With a different case, paper, 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 scissors, scissors, scissors. Correct? One way of patterns you look into. The other one is rock, paper, scissors, rock, paper, scissors, rock, paper, scissors. This one is like this, tie, tie, tie. So the outcome you can have the pattern. Anything has patterns. So if you can see those patterns and identify them, right? So lose, 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 and win, win, win. Now, you might say which one I should consider. Depends on how efficient you are with your coding and which one make the code better. I would consider this, right? So I would use the combination of both. The outcome matters. Why we have to think about it? Why we doing this? All these comparison. Because we want to see who's the winning, who's the outcome is. So I focus on the outcome more. So I can do this. I can go ahead and find. Now, looking at this, my life will be really, really easy. Considering this idea of when the objects are the same, right? So you don't need to say the U is rock and opponent is rock. U is paper, opponent is paper, and you have scissors and opponent has scissors. If the objects are the same, like the U and the opponent has the same object, despite the fact what it is, and that's a tie. So that nice little touch actually eliminate three of these. So this guy can go away. So this, all the ties can be written in this case. That's okay. If the computer equals then the user input right away, and then I'm going to say that's a tie. So easy to say it's a tie, right? So that is a case that eliminates these 3 out of 9, right? Now, what if it's not a tie, right? So else, what else if it's not a tie? What do we do? Okay, so if it's not a tie, then you can check for other situations. What other situation we're dealing with here? One is who's the winner, right? So when you win, it's 3 cases. I do all these 3 cases here. So when it's okay, if it's like that case, if it's else, you can go if. I want to check that if the computer has the rock, right, and I have it on the top though. And then you have the user input is scissors. Right? That is the case one. Or let's see who all the cases. The computer has the paper and of the rock, or computer has the scissors and then in these 3 cases we can easily say you won. Okay. Now what if it's not that case though? What do we do? Then so this is when they're the tie. If it's not tie, we check if you win. And if it's not a tie and you're not winning, then what is left is just computer. Simple put. This can be a little bit more further simplified. Basically, you don't need to. You can do that, and this on one scope. So, okay. Trying to show you what I do here. All right. So either it's a tie, you win, or computer wins. See, that is a nice intermediate group, upper intermediate way of coding. And this is primitive. Both of them works, but you have to get to the point that you can see patterns and efficiency matters to you. 1 cent for another. Okay. I'm gonna test that and then parking lot it. And if you guys have any question, you more. What am I missing? Uh, problem of. There we go. I think with scope wise, I missed it. Because I delete some of the scope. That's a main class. That's a main function. Yeah. That's it. All right. So let's see. Paper. Oh, you see the top one says you won. Bottom one says you won. Do it in capital, right? Here you go. You select paper, computer, select scissors, and you won. Isn't it the other way around? I mistyped that. I think the computer scissors cut it, so you lose, right? You win. Apparently the other way around, right? The computer has the rock. That's why you shouldn't follow the table blindly. And then you have a scissors, the computer wins, which is you lose. Yeah, I made that mistake. These are all you wins should be you lose. And yeah, let's flip the logic. See, the bottom one is also fit. Easy to fix. I think the table was wrong. I just follow that table. That's why we do testing, you know. There you go. That is a job. If you face a problem, you fix the problem. All right. Paper and scissors. Scissors cut the paper. That's it. Rock and rock. Rock and paper. Paper covers the rock. You lose. Scissors. Scissors and scissors. Scissors and rock. Rock crush the scissors. You lose. Okay. So that will basically conclude today's. So hopefully you guys can go play around with this. If you really want to play around with that, go do the Sheldon Cooper version of this game. If you don't know what that is, search it up and improve it. It's a rock, paper, scissors, spark, snake, spark, something like that. Rock, paper, scissors. Spark, snake. Snake, spark, something like that. Just search that. Haven't watched it in ages. All right, so Sheldon Cooper, rock, paper, scissors, lizard. Spock, Spock, and lizard. Let's see, you can do that. That is five power to the. That's 25 outcome. Let's see. Yeah. Oh, there we go. That's for you to go watch and. All right, that's it. I'm gonna. I was have another class after we finish up. Let me stop this. There we go. Just go back to the team. Okay. This is the participant. I'm gonna put this in the chat. Oh, oh, okay, okay. Sorry, someone. I did not see your chat though. I was asking, but we have to parking lot that for the next week. So you want to deploy how to deploy the Java apps online by connecting it to the data. That is like your Java E you're talking about. Java Enterprise. You're still there? That's SE? Okay. I don't think that's SE though. Well, Java like Java beans and stuff like that. Like, okay. We can look into it next time. For now, I'm just gonna put this code here. But yeah, like we start, well, that's a little bit more intermediate to advanced, I would say. So do cover that next time. All right, folks, I have to go, unfortunately. Next time, I hope I can get my camera going. And we're gonna have that next week, Saran, the beginning of the session, I guess. All right, so I'll have to leave. So you got this? I guess they did. Okay, so see you guys later. Take care.